Welcome to The Explainer. The artificial intelligence boom has been driving the global economy, creating trillions in value. But what if it's all built on a shaky foundation? Today, we're investigating a potential fatal flaw that could bring the whole thing crashing down. There's a bit of a chill starting to creep across Wall Street. Some of the world's sharpest investors are quietly starting to bet against the AI gold rush, which kind of suggests that something behind the scenes might be starting to fray. Take Michael Burry, the investor made famous in the movie The Big Short for predicting the 2008 financial crisis. Well, he's placed a massive bet of almost $200 million against a key AI chipmaker. And when a guy like that makes a move, people definitely pay attention. And he is not alone. Tech billionaire Peter Thiel's fund recently sold its entire $100 million stake in NVIDIA, the company whose chips are basically the backbone of the entire AI revolution. So this raises a huge question, right? Are these investors seeing some kind of fatal flaw in the AI story that the rest of us are missing? Are they seeing a bubble hiding in plain sight? So let's get into it. To understand why these big shot investors are getting so nervous, we need to look at the one simple idea that's been fueling this entire AI industry. The current boom is built on a technology called deep learning. The easiest way to think of it is like a digital brain with artificial neurons stacked in a whole bunch of layers. You feed it massive, and I mean massive, amounts of data, and it becomes incredibly good at recognizing and predicting patterns. AI researcher Gary Marcus has this fantastic way of explaining it. He says they're basically just autocomplete on your phone, just really sophisticated. In other words, they're just really good pattern matching machines, predicting the next word based on everything they've ever been trained on. So, for years, Silicon Valley has been operating on this one simple principle, known as the scaling laws. The idea was pretty straightforward. To make AI smarter, you just had to make it bigger. You just pull these three levers, add more neurons, feed it more data, and throw more computing power at it, and you're pretty much guaranteed better performance. And for a while, man, it worked spectacularly. I mean, just look at the jump from OpenAI's GPT-3 to GPT-4. The model size exploded by about 10 times, and its score on a key intelligence benchmark just shot way up. This kind of progress is what fueled all those claims that we were on a fast track to human-level AI. But here's the problem. These weren't really laws of physics. They were just an observation of a trend. And now, the cracks in that trend are really starting to show. Gary Marcus has this brilliant analogy. Just because a baby doubles its weight in its first 18 months, you don't expect it to keep doubling in size until it's a trillion-pound college student, right? Growth that's predictable in the short term doesn't mean it's going to continue forever. And that's exactly what researchers are finding now. Even if you make a model 10 times larger, you're no longer getting a model that's 10 times smarter. We're hitting a point of diminishing returns, and this reveals a fundamental limitation to that whole bigger is better approach. At their core, today's AIs are still what you'd call giant statistical machines. And that leads to three pretty well-known types of failure that just scaling up can't seem to solve. Okay, first up, hallucinations. This is when an AI just confidently makes things up. One actor found an AI-generated biography claiming he was British. He's not. And as this chart shows, even the best models still do it a lot. A 2024 study found GPT-4 produced false information almost 29% of the time in factual tests. Second, they fail when they're faced with outliers, things they haven't seen thousands of times in their training data. A self-driving car might be great at navigating normal traffic, but it might not even recognize a truck tipped over on its side as a hazard, just because it's such an unusual thing to see. And third, they are simply running out of fuel. I mean, AI models have already consumed most of the high-quality text on the internet. Experts at Epoch AI estimate we could completely run out of new data to train on within the next decade. You can't just invent 10 more internets to draw from. So you have these fundamental technical limits, and they're colliding with absolutely staggering costs. In this combination, well, it makes a very strong case that the AI industry is an economic bubble just waiting to pop. The cost to train and run these models is astronomical, not just in dollars, but in energy. A single ChatGPT query uses nearly 10 times the power of a Google search. And just take a look at these projections. Data centers, where all the AI processing happens, are expected to see their power demand soar by 160% by 2030. That's just unsustainable. But here's the twist. Unlike the dot-com bubble of the late 90s, the companies at the heart of the AI boom, we're talking Nvidia, Microsoft, Google, these are financial titans making hundreds of billions in actual, real profit. They have deep pockets and can afford this arms race. For now. So if just making models bigger is a dead end, does that mean AI progress is about to hit a wall? Not necessarily. There might be a different path forward, one that goes beyond that bigger is better mantra. Many researchers, including Gary Marcus, are advocating for a return to an older, really powerful idea that got overshadowed in the deep learning gold rush. It's a hybrid approach called neurosymbolic AI. So the key here is combining the best of both worlds. You get the intuitive, pattern-matching power of today's neural networks. Think of them as the artist, and you pair it with the strict, rule-based logic of classical symbolic AI, which is kind of like the fact-checker. And here's the most important part. These symbolic systems don't hallucinate. And this isn't just a theory. Google DeepMind's AlphaFold 2 system used this exact hybrid approach to solve one of the biggest challenges in biology, predicting how proteins fold. It was such a monumental breakthrough, it was recognized with a Nobel Prize. We know this works. This leaves us with a final, pretty provocative thought. The AI industry is spending trillions of dollars on one big bet, that just scaling up our current approach will solve everything. But what if that bet is wrong? Perhaps the future of AI isn't about making it bigger, but about making it fundamentally smarter.